session, which is Victor Alaya. It's a well-known developer of different kinds of software since a long time. And I leave the floor to Victor.
Thank you. Thank you very much to everyone for coming. So yeah, I'm going to be talking about this library that we have in Carto, the analytic toolbox. So yeah, I'm Victor. I come from Carto. In Carto, we do data visualization. Maybe some of you have been at the presentation by my colleagues Alberto or Felix that they show very impressive renderings and with large data sets. But we also do analysis, which might not be so attractive or impressive or so sexy to show, but we do a lot of analysis, and these libraries what is underneath all our analytical tools. So this is what I'm going to be explaining today. A little bit about myself. I've been working in Carto for the last year. Before that, I spent like roughly 10 years developing QGIS stuff, developing quite a few plugins. If you've seen the car plugin before, that's something that I did. If you've been to the talk before, I also wrote the original OSGeo toolbox integration to QGIS, so basically doing a lot of stuff into QGIS. And my main contribution, I guess, to the open source GIS world is the QGIS processing framework. And if you're familiar with that, you are going to see that some of the things that I'm going to present here today, you're going to see that there's some similarities, because actually the work that I do in Carto basically is to bring all that expertise that I got from doing spatial data analysis in QGIS into the Carto platform. Okay, so in short, there's some idea that I want you to take home is that these analytic toolbox that we have is basically a collection, an homogeneous collection of spatial analysis functions that works across data warehouses. And I would like to put the emphasis here on this homogeneous, because it's a set of functions that work more or less the same in different data warehouses, and that's the idea that we have when creating these. So you should be able to do that spatial analysis, the same spatial analysis, no matter what data warehouse you are using, right? So this is the basic idea. I'm going to be talking about this collection of functions. So a quick word about databases and data warehouses. I haven't seen a lot of presentation talking actually about data warehouses. In case you're not so familiar, databases, I guess everyone knows what a database is, right? You put data into a database to manage that data. You can insert new data into a database. You can make queries to the database. In general, databases are capable of handling a lot of simultaneous requests. The idea of a data warehouse is based on a database, let's say, but the main goal is not to be able to make these queries or to insert data or to just get the result of those queries, but actually to analyze, right? To that data that is in the database, be able to analyze, maybe do full scans, that you need to extract some more information from there. So they're not so well prepared maybe to have a lot of concurrent access at the same time, but they're better prepared to be efficient when doing those analyses, right? So these tools I'm going to present, they run on most of the most popular data warehouses nowadays, and what we do is actually to add that special capabilities into them, right? So what happens is that we have different support for spatial operations in data warehouses. There are several data warehouses. All of them support spatial data. So if you're familiar with the idea of Postgres and PostGIS, like Postgres doesn't have support for spatial things, but PostGIS adds that, the support for native spatial objects, and then the functions to do things with those objects. Data warehouses, most of the most popular ones, they have support for these geographies or geometries, but then they don't have such a large array of functions to actually analyze and work on them. So what we do is we use that support that they have, but we enhance the tools that you can find in there, and we enhance the capabilities of these data warehouses by adding these functions that form the analytic toolbox that we have in Carto. Right? So the analytic toolbox creates like a common ground for spatial analysis. As I said, we try to have something homogeneous that, same functions that run across data warehouses, so you can do the same analysis, perform the same analysis, spatial analysis in different data warehouses, right? The data warehouses that we're supporting at the moment are these 5 ones. The support for Databricks is not so strong or stable, but BigQuery, Snowflake, Redshift, and Postgres. Postgres is a database, but you can have a, have it deployed somewhere and be working as a data warehouse, even if the performance is not like the one that you're going to get with BigQuery or Snowflake, to name those two ones. But yeah, what we have is a set of functions that you can deploy on these data warehouses, and then you have those functions that you can use to analyze the data that you put in there, right? What we try to do is to change that idea of ETL. If you haven't heard of that, it means extract, transform, and load. So what we do is try to change that approach. Like, you extract the data, you have your data, then you transform your data, do whatever you want with them, analyze and change them, and so on. And then you load them, you put them in your database where you're going to share them or do whatever with them in the database to store them there. Is to actually switch, flip those T and L, the transform and the load, so you can extract the data, then you just put it on the database, and all the transformation that you need to do, they're done on the database, right? With the advantages that might have from many different points of view. So we're trying to do that. This is something that data warehouses try to do, actually change from ETL to ELT. We are providing the tools to make this possible in the spatial data, right? So in the spatial side of things. You can do that with a normal data warehouse if you don't have special data. If you have special data, with the help of the functions that we're sharing here in the analytics toolbox, you can also do that with the special data and relying heavily on the special component of your data. This is a quick summary of what we have so far. You can see the number of functions related to spatial data, to spatial types in the different database and data warehouses. As you can see, of course, PostGIS provides a lot of them. Even in that case, we're adding new stuff, and in others, they're not so well prepared for that. They support, as I said, spatial data, but they don't have such a large array of functions, so we add quite a bit of them. And the idea is to add the same thing in all of them. Like, one of the functions that we might be adding in BigQuery, we might not be adding that to PostGIS because it's already there. But in the end, you're going to have the same things. The idea is that you can do something in PostGIS, but then with little changes, you can go to BigQuery and do something similar. Of course, there's changes in the SQL dialects, but the part that actually performs the spatial analysis, we try to have the same thing across all these data warehouses, right? So, as I said, in some cases, we might be adding something that is missing, but it's not missing in another case. I can put you an example. Snowflake recently introduced something as simple as a buffer, but there was no buffer function in Snowflake. There were other things, but no buffer. So we were adding a buffer in the analytics toolbox to Snowflake. Of course, we were not adding that into BigQuery and PostGIS because that was there from the very beginning, right? So that's the kind of thing. Now, it doesn't make so much sense to have that buffer in Snowflake because there's a native buffer, but the analytics toolbox provided that, and it will change according to how the data warehouses themselves change. Right. An important thing to mention here is that there are two parts of the analytics toolbox, what we call core versus what we call advanced. I'm only going to be discussing here the core part because it's the open source one, and this is an open source conference. There's an advanced one, but that's not open source. So I'm just going to mention that so you get the full image. But those are functions that are not available for the general public, and they are not open source. Right. Most of the stuff that we do in those functions is SQL, but we also use JavaScript and Python because these data warehouses, they support create and store procedures that rely not only on pure SQL code, but also they can rely on JavaScript or Python libraries. So what we do sometimes is to actually implement the functions, and sometimes we just wrap libraries that exist, like JavaScript libraries or Python libraries, right? This is a good overview of the library, I would say. The core part, this is the part that is open source. As you can see, there are some different modules, as we call them, right? An important part that I will be talking about that later is built around spatial indices. That's one of the most popular parts and the most powerful parts of the analytics toolbox. Then we have this advanced and domain-specific. Those are more complex functions. So there are functions that have a more complex logic underneath to perform more specific tasks, or some of them, like you see, routing or LDS, They don't have all the analysis in the data warehouse itself, but they connect to services like TomTom or Here for doing routing or LDS. So it's a function that is more complex and is able to do more stuff. Those belong in the, as I said, in the advanced category, right? So as I mentioned, the spatial indices are something that we use a lot within Carto, and we want people to use that a lot. It's really helpful tool, and so far there's no support for that in data warehouses. So what we have been working a lot in the analytics toolbox is to actually add special indices, like, you know, kind of things. I had a demo, but I'm not going to show it. It's actually like something that was computed from, you know, using these type of analysis, and then you can, this is a case of an S3, H3 special index. So we just simplify data using this special indices, all done through the analytics toolbox, and then we have tools to create tile sets with the special indices that also rely on the tools in the analytic toolbox. Right? We have support for QuadBean, H3, S2, and Geo has most of the work that we actually do on the most powerful functions around special indices. They are related to QuadBean and H3. So, and that's what we use for many of the things. If I mentioned this DeckGL demos that my colleagues did the other day, they heavily use this kind of things, and as I say, underneath all that is the analysis performed by the analytic toolbox, right? You can install it yourself, of course, if you want to use that. Just go to the repo. You can install from there. It's an open source project. You can deploy that with the scripts that we provide. But for some of the data warehouses, they're already deployed. So if you use BigQuery, there's a Carto OS, Carto open source project in BigQuery that you can use to do something like that. If I want to get the coordinates of the center of the H3 hexagon with that ID, you can just run that in your BigQuery console, and it's going to work, right? So the same for Snowflake. It's always already available there in the applications. I don't get the name now. The place where you find the Snowflake applications, you can find it in there also. Our extension with all the analytic toolbox methods. So the idea of the AT, of the analytic toolbox, is to serve as a base tool for other things. That's what we do internally. I mean, we have that. You can use them directly in the console. We're running normal SQL code, calling these functions, but we also use that to build other products within Carto, and we want people to use it that way. So not just stay there, not just use that directly in the console as a set of extra SQL functions, but also to build other tools. For instance, this is Carto Workflows. This is a tool that it's built on top of these ideas of the analytics toolbox. As I said, you're going to recognize probably some of that previous work of mine that I mentioned with the QGIS processing framework. There's a QGIS modeler. This is the equivalent of the QGIS modeler, but on a data warehouse, and you just put pieces together. What it does is to actually translate the graphical language into SQL. It creates SQL code based on that, and that SQL code uses the analytics toolbox to actually perform the operations that are defined there in those components that you link graphically in the modeler, right? So we use the analytic toolbox as the foundation for our own tools, and as I said, that's something that we would like other people to also use as well, build more powerful things on top of our functions, right? These products also, they shape the analytic toolbox, right? So when we add new stuff into the analytic toolbox, we're not only thinking about how they can be called from the SQL console in BigQuery or in a Snowflake, we also think about how it is going to be used in something like the modeler. And the modeler, for instance, these workflows in the Carto platform, these workflows, they have a probably more GIS approach. They're not so, like the approach that you have when you use it from the console might not be the same that when you use the Carto workflows. So that somehow shapes the way we, you know, the analytics box and the way we implement functionality in there. So there's a bidirectional relation between the toolbox and the things that we build on top of that. And the same might happen when, you know, if you decide to build something on top of that, you're going to find several different versions of some of the things that some of them might be more suitable for being used for a given product that you're building on top, instead of just calling the function from the console, right? What is next? And we have as I said, a set of function, but of course this is growing. Where are we going next? So of course we want to add more tools. We want to add, there are tools that are still missing, the things that, for instance, you might find in PostGIS, but you still don't find it in BigQuery, even with the analytics toolbox. So we want to, fill all those voids, and so in the end we'll have all the function across all the data warehouses. That's something we still have to do. We're constantly thinking about large data sets, so we need better performance. Some of the functions in IT Toolbox, they work fine with huge data sets. We have added recently a lot of improvements for the special indices functions to work with even larger data sets and things, but we still need to improve the performance, and we're always trying to get better performance. And we're also trying to add some experimental stuff. We're trying to, try some new things, and one thing that I have added here that I wanted to show you is how we're trying to add artificial intelligence into that. It's a very trendy thing, and we're trying somehow to incorporate that into the analytics toolbox, with the main idea of allowing people to use the analytics toolbox or workflows, as I showed before, to be able to use that in a more natural language, which is in the end what you have with AI now, with this language models. And I have a couple of quick samples for you to show here. This is a function that is not currently in the analytics toolbox, but it will make its way to the analytics toolbox. So you can select a query to OSM in natural language, right? I want the healthcare facilities in the south of Spain. And that's how you define the map in this Carto Builder. That's the tool that you use to create. You can add there, select whatever from this data set in normal SQL language, but you can also rely on this function to give you this data set that you have defined that in a natural language, right? So that's something that we're experimenting with. Also in Carto workflows, relying of course on functions underneath in the analytics toolbox. See, I'm doing a filter in here, but the filter condition is not a normal expression, right? It's just rows with names that have less than 6 characters. I'm expressing that expression, and I'm writing it in English instead of in another way, in a more technical way, let's say, that the computer can understand, and that works. And you can generate a new column with AI. In this case, I'm applying that filter to the layer before, and here what I'm doing is, okay, I'm adding a new column. What is the new column? Usually you can say is this column multiplied by 2. You use a mathematical expression. Here I'm saying like the capital of the state. That's what I'm saying. And it can actually take the layer from here, the original table, filter it, get me the states, and then add the capital, right? So that's some more experimental thing that we're doing, because we also want to expand the reach of these functions to this new territory. This so far is we're only implementing that in BigQuery, because there's this generative AI in BigQuery, that some support for that. In other, we still haven't tried so far to do that. If you have any questions, of course, feel free to ask me. Thanks again for coming. I hope that you found that interesting. Thank you.
Is it working? Okay. Thank you, Victor. Are there any questions? Don't be shy. Come on, I'm sure you have some. Oh.
Hi, Victor. Great talk. As you said, AI is really cool and really trendy, but it's also famously returns a lot of nonsense when you ask it questions.
Definitely.
Does your AI integration cite the resources?
Sorry, I couldn't understand that. You say if
the AI integration, does it cite the resources? So it just not puts the point on the map, but it also says where did it look and where did it found the results?
Oh, you mean where it comes from, the data? Okay, there are different approaches to that. I mean, if getting into the internal part of that AI, depends on the component that is shown. The first component, that is like the filter, what we do is actually use the AI to turn that into SQL code. So we send the request to the AI and say, this is the condition expressed in English, express that in SQL. And then we got that SQL, and then we execute that SQL. That's one of the things. In the other case, when the names of the capitals, what we do is just take the table, take the names of the states, which is the column that we're basing that on it, and then we send that to the AI and say, okay, here's the list of states, and the user wants the name of the capital. And it comes back with no information about the sources. You know, there's a classic thing about, you know, where it comes from, where did you learn that? But we just get the result and then parse that result and include that into a new column. That's how basically how it works. Right? This is a very experimental thing, and actually at the beginning we wanted to do more things with AI. There are some things we've been doing with AI not related to Analytic Toolbox. Something that actually is very good, we have seen that is very good, is to define things. Like if you see the workflow that I showed before, one thing that probably is going to be soon available, because it's more, we feel it's a better use of the AI, is to actually write your model, right, your workflow, and then there's an option to document that. And it's super good that you take that SQL that is generated, you send it to the AI and say, like, explain to me in 50 words what this thing that has 500 lines of code does. And it's super accurate. And that's another use that we think it's better than actually the processing. But we're trying to, you know, get the SQL processing linked to AI. But if you want my honest opinion, I think that at the moment there's more room for AI in these sort of things, like describing things or commenting things, adding labels, than actually working with the data. We're trying to explore that, but so far we have seen is that, yeah, in certain circumstances it can be useful, but it's not as great as you might think. Like, oh yeah, now I can just send a phrase and it's going to generate. Like something very simple that we tried, for instance, to add was functions that rely on AI to generate sample data. Like not random data, but some meaningful sample data. And we couldn't make it. It was like, it looks like very simple, like you asked the AI, give me some sample data about airports or whatever. And it couldn't, yeah, there were always something that was not correct. So at the current state of AI, I would say that we're trying to experiment with that to find the 2-3 little things that might work and might make sense. But in this process of trying new things, we're finding a lot of things that we try and say, like, no, this is not so useful. So yeah, that's my honest opinion about that, about the integration of AI into that kind of analysis. Don't know if that answers your question more or less. Okay, cool, thanks.
Other questions? Don't be shy, really. No more? You're sure? Okay.
I was just wondering what the roadmap was to get all the ST functions out of PostGIS covered.
Well, actually, the roadmap is not to have all the ST functions. I mean, we take inspiration in that collection of functions, but it's not just, you know, since PostGIS is the one with most of the things, just migrating that to all the data warehouses. It's basically adding functions. Like many of them are already in Postgres and in PostGIS, and we try to clone them, let's say, get inspiration from them. But some of them, maybe we're not even going to port them because, like, okay, they are in PostGIS, but we don't find them so useful for our customers or in general, right. Or we prefer to implement something different that is not yet in PostGIS, so we put different. So it's not just getting PostGIS everywhere, but it's about having an homogeneous set of functions that, for sure, will include a lot of functions that are already in PostGIS, but not the whole set. So that's our approach.
Thank you.
There is still time for some questions, if you have some more. Come on, one last one. No, apparently not. So I want to thank you, the 3 speakers of this session. Yannick, Robert, and Victor. And so thanks to all these, in general, thanks to all these guys, to all the nice guys that are developing, maintaining software for the users. So we really are very grateful to all of you. And thank you for being here for this session. And now we have a break, so you can take some break right now. And then later on we will have the last presentation here and the final session for the closer session for this conference. Thank you very much for being here today.